Private addresses. Of all of these classes, Class A, we have private addresses ranging from 10.0.0.0 through 10.255.255.255. Of Class B, we have 172.16.0.0 through 172.31.255.255. Class C private addresses are 192.168.0.0 through 192.168.255.255. There is a range of addresses called loopback addresses. Those are the first octet is 127.x.x.x. Now, .x simply means anything. So any address beginning with 127 is a loopback address. We also have what's called an auto-config address. Those are 169.254.x.x. 169 being the first octet lets you know that an auto-config address has been applied to a device. And usually what that is when the computer boots up and does not have an address for a device or has not been assigned an address for a device, the first octet is going to be 169. The second octet will be 254. We hadn't talked about loopback addresses yet, but that's a special address. Generally, it's used for testing. We'll get into that a little later. Now, of all of the internet-ready IP addresses, in other words, those that are sold by IANA, your ISP or Internet Service Provider has purchased a stack of IP addresses that are Internet ready. What they do is they lease those addresses out as people require them. They have servers and they use a protocol called DHCP, which stands for Dynamic Host Configuration Protocol. Now, when you go online, if your ISP rents you an IP address purchased from IANA, they lease it to you for a particular period of time. Once that lease is expired, what they will do is give you a different address to lease, or they may let you lease the same address. Usually you're unaware of that. Our IP addresses consist of 4 8-bit octets. What this means is 8 bits per octet times 4 is 32 bits. So with an IP address of 32 bits, the total number of available IP addresses is going to be 2 raised to the 32nd power, which is 4,294,967,396 addresses. When this addressing scheme was initially conceived, they thought we would never run out of IP addresses, but in fact, we already have. That's why we had to go to a scheme called IP subnetting. We won't get into IP subnetting at this point in time, but I will say this. IP subnetting allows you or a company to take an internet-ready IP address issued by IANA and divide it into as many individual networks and hosts as you may need. This is done by calculating an internal subnet mask. The subnet mask is a way for you to define which bits are used for a network address and which bits are used for each host on the network. Don't worry, there is a method to the madness, and it works so well that subnetting actually delayed the release of a new IP version that would help give the networking world a tremendous amount of valid internet-ready IP addresses. The new IP version is version 6. The version that is being used today primarily is IP version 4. More on that later. While we're at it, there is another IP addressing scheme that prevented us from having to scrap the IP version 4 and move to IP version 6 out of necessity. This scheme is called NAT. NAT stands for Network Address Translation. This scheme allows multiple users, multiple clients, to actually share a single internet-ready IP address. And we need to touch on routers and switches, networking devices, for just a second. Switches create networks. Routers connect networks. That's key to remember.